what we want to talk about is how electrolytes behave in aqueous reactions.
So this is going to be figuring out what they do at the submicroscopic level, isn't it? Okie dokie.
All right. So an example of aqueous solutions being poured together would be like lead iodide and potassium nitrate, which we already know about.
Yeah.
We already know both of these are soluble.
Right.
They're both strong electrolytes.
So this is a before and after situation, and those reactants are before. They're in separate beakers?
Right. The potassium iodide is in a beaker. The lead nitrate is in a beaker. You pour them together into the same beaker, and you get, afterwards, this stuff.
Yeah, you get a...
This stuff.
Yeah, you get a precipitate.
You get lead iodide and potassium nitrate.
And everything follows the solubility rules. I see the potassium, I see the nitrate, then I see the exception to the iodide rule. Okay.
And this is just our typical double replacement reaction. There's nothing very difficult about this.
Balanced and with states of matter.
The thing is, like you said, we can look at this even closer. All right, this, if we look at it even closer, is going to look like this. The potassium iodide here is actually soluble.
Okay.
So it's going to break apart when you put it into solution. So it really doesn't look like potassium iodide. It really looks like potassium ions and iodide ions.
Okay, where did the two come from, Mr. Kane, in front of the potassium ions and the iodide ions?
Well, it was a balanced equation to start with. There were two potassium iodides. That means that there were two potassium ions and two iodide ions. So these twos that came in front of the potassium and the iodine now you notice that the lead doesn't get that coefficient, the lead ion, simply because it didn't have a coefficient in front of it. But because this 2 is here, this 2 does apply to the nitrate, so that means there are two nitrates. And we don't write the subscript 2 this time, we write it as a coefficient.
Okay, because you're kind of taking count of all the ions, the ratios of ions, yeah?
Exactly. We want the ratios of ions now that we've written ions, so we write the 2 out in front of the nitrate.
Okay, so a coefficient will apply to the entire substance, the ions in the entire substance, right? But a subscript will only apply to that particular ion.
That's right.
Okay.
The lead iodide is not soluble, which means it doesn't dissociate. So check this out.
Stays together.
It stays together. You don't have to write the ions because it doesn't turn into ions.
Because you're writing all the strong electrolytes in this line, aren't you?
Exactly.
And lead iodide is not a strong electrolyte because it's not a soluble salt.
Correct. And then the last two things are the potassium ion and the nitrate ion. They both get 2's in front of them because there was a 2 in front of potassium nitrate.
So you're actually submicroscopically taking account for every ion in the mixture.
Mm-hmm.
All right. And that line is atomically and electrically balanced, isn't it?
Yeah, it's balanced atomically and it's balanced electrically. If you add up all those ions, you should get a neutral on both sides.
Okay. The first line, we call that a molecular equation, do we not?
Mm-hmm. This is our molecular equation. You might want to write that down because we'll be referring to it as molecular equations. And the second line, how do you refer to that?
I refer to that as the CIE.
CIE.
Yeah, complete ionic equation.
Yeah, okay, the complete ionic equation.
That's what it's showing. It's showing all strong electrolytes in their ion form.
It's a complete diagram of all the ions in the equation. Okay.
Right, okay, so now what happens?
Okay, well, now, we want to talk about what a spectator is.
Okay, a spectator is somebody who watches and does not participate.
Like at the football game.
Like at a football game.
Or the basketball game.
Yep.
Or on YouTube. You just sit there and don't take notes, right?
Yeah, that would definitely be spectators.
Okay, so what role does a spectator play?
None, they're just watchers. They don't play any role.
Oh, okay. So let's take a look at that equation again.
So this is the complete ionic equation we just had up.
Do we have any spectators in here that aren't really doing anything?
Yeah, 2 of them.
Yeah. There's something called a spectator ion, guys. Spectator ions don't do anything.
Are those ions that are not involved in the reaction, yeah?
Yeah. So potassium ion and potassium ion on both sides, it doesn't really do anything. It's still a potassium ion. Same thing here with the nitrate ion and the nitrate ion. On both sides, it didn't actually do anything. The only thing that did anything was the lead ion and the iodide ion. They became lead iodide.
Well, aren't spectator ions going to be pretty easy to spot? Aren't they the ones that are not in the solid?
Yeah, you know what? If you look at the product side, They're the ones that aren't in the solid.
So if
Yeah.
lead and iodide make the product, then the potassium and the nitrate don't, and they're the spectator ions.
Right.
Well, that's easy.
Okay. So we can write what's called a net ionic equation where we remove these spectator ions and just kind of pointing out, okay, potassium didn't do anything. It's a potassium ion on both sides.
So they kind of cancel.
Yeah.
2 minus 2 is 0. So does the nitrate. Okay.
And the nitrate ion does also. And we just put a nice X over it. And that's pretty much it.
That leaves just the iodide and the lead. Which
That leaves just
makes
the iodide and the
solid.
lead. So we can write what's called the net ionic equation where we don't write what we just crossed out.
Okay, get rid of the spectator ions.
So we get 2 iodide ions, a lead ion, and we get lead iodide.
Okay, so let me sum this up a little bit, Mr. Kane. Let me see if I get this right. This whole unit revolves around double replacement reactions in the hopes that a precipitate forms based on solubility rules. Is that
Yep.
correct?
We've already learned that. Mhm.
Okay. Soluble salts are those that dissociate 100% based on solubility rules, right?
That's right.
If a precipitate forms, you get a reaction.
Mm-hmm.
What happens if one doesn't form?
You don't get a reaction.
So if we don't get a precipitate, you just write no reaction, which we'll probably show in a little bit, yeah?
Yeah, we'll show it in an example.
All right, so we get a double replacement reaction, and we write it out and balance it and apply states of matter based on solubility rules, and that's the molecular equation.
Mm-hmm.
Then we dissociate all strong electrolytes based on solubility rules, and that's the complete ionic equation.
That's right.
Then we cross out any spectator ions and just write those ions involved in making the precipitate, correct? And that's the net ionic equation.
That's called the net ionic equation, or as you like to call it, the NIE.
The NIE.
Another example here. We can take solutions of silver nitrate and zinc chloride and combine them together, see what happens. Now this first part should be pretty easy, right?
Yep.
Silver nitrate should be aqueous because it
Yes.
says solutions,
Right.
although I saw you looking at the solubility rules.
Just making sure.
Really? Okay.
Yeah, we're good. We're good.
All right. What about zinc chloride? I saw
Yep,
you looking there
still
too.
good.
All right, so ZnCl2 is...
Chlorides are soluble unless silver, mercury, and lead. That is neither silver, mercury, nor lead.
Okay.
So it is soluble.
So let's see. This is going to form silver chloride.
Ooh, and that's going to be soluble.
Nope. Is it?
Yeah, it is. Chlorides are soluble. Oh, I'm sorry. Oh, and that's going to be insoluble. That's my precipitate.
Because that's an exception to the rule on
That's an
chlorides,
exception
right?
to the rule on chlorides.
Okay. And then we've also got zinc nitrate, which we better double check.
Well, nitrates, anything attached to nitrates are going to be soluble.
Oh, that's
so you
right.
don't even
There are
have to
no,
look.
there
Yeah,
are no
there are
exceptions.
no exceptions to the
So
rule.
we'll just write AQ here.
If it's a nitrate, it's soluble.
Okay. So this is my molecular equation, then.
All right, so we got to balance it, yeah?
Yeah, we have to balance it. Let's see. I think it's kind of funny. They don't call this a formula unit equation. They call it a molecular equation. There's no molecules in here.
Yeah, that's true. It is weird because they all revolve around ionic salts and they all revolve around double replacement and aqueous ionic salts. So I don't know.
Kind of misusing the word, but okay,
Yeah.
as far as I understand it. All right, let's see. The next thing we got to do is we got to write a complete ionic equation.
Okay.
So anything that dissolved is going to be,
Not dissolve, dissociates.
I'm sorry, dissociates. Not just dissolves, but dissociates.
Or disassociates. Strong electrolytes. Stick with that. So based on solubility rules,
Okay.
silver nitrate is a strong electrolyte,
Okay, charge. There we go, charge.
and the coefficients apply to both the silver and the nitrate. Zinc chloride is a strong electrolyte, according to solubility rules, and that subscript only applies to the chloride.
Mm-hmm.
And I already know, I can already see what the spectator ions are going to be.
Well, hold up. Let me write all this out. You're quicker than I am. I kind of like the precipitate because it was easy to write. I didn't have to think about it.
Yeah.
2 nitrates, and they're both aqueous.
Now this is the complete ionic equation,
This
correct?
is the complete ionic equation. And now we have to identify our spectators.
Well, that's easy. Underline the
I should write CIE first.
CIE.
CIE. There we go.
underline the precipitate for me.
All right, here's the precipitate.
So if the silver ion and the chloride ion make the precipitate, they are not the spectator ions. So that means zinc and nitrate.
Now I just have to rewrite it, right?
Yep, rewrite it.
So 2 silvers that are both aqueous, 2 chlorines that are aqueous, and they form 2 silvers, silver chlorides, that are not aqueous.
So those are the ions that are involved in the reaction, because it is a precipitate reaction. One small little detail, Mr. Kane. According to the rules of balancing, if you can reduce your coefficients, if you can reduce all the coefficients, reduce them, and those can be reduced down.
1, 1, 1. There
and
we go.
that's the net ionic equation?
This is our net ionic equation. Solutions of magnesium nitrate.
Now nitrates are all aqueous, so that should be aqueous.
Sodium chloride, yeah, because sodium's group 1A.
So again, these two are sitting in separate beakers, and then you pour them together, correct?
Right,
Now
beaker plus beaker.
Beaker plus beaker. Okay, now you
Okay.
poured them together.
So now we're going to get magnesium chloride.
Soluble.
That's soluble.
All right, I see a problem
And
forming here, Mr. Kane. Go ahead.
I don't see a problem forming here. There's
No?
nothing forming here.
Yeah, that's what I'm
And
saying.
sodium nitrates, and sodium's
That's
a
gonna
group
be
1,
aqueous, yeah.
and nitrates are all soluble. This is
Yeah,
aqueous.
this is all aqueous. There's no precipitate reaction here, Mr. Kane. What do we do now?
How do you know that?
Well, no precipitate formed on the right-hand side. There's no solid.
Oh, yeah, there's no solid.
Nothing
Awesome.
happened.
This one's easy.
Yep, no precipitate, no reaction. This
No.
one's easy.
No reaction happens here.
You got nothing. All you got at the end is still a solution of nothingness that just looks like water.
So all I've got to do here is just predict my products and, oh, hang on.
Yeah, don't forget to balance.
Balance. I'm supposed to balance these. So let's see. 2 and another 2 here. Okay. So it's balanced now.
Can we have like 8 of those? That's kind of nice.
All right, guys. Speaking of 8 of them, here's your homework.
Oh, there's not 8. Oh, phew.
No, there's not 8 on the homework. That would be silly. All right. Write a balanced, a complete, and a net ionic equation. So you're going for three equations for each of the 2 problems.
Unless one of them's no reaction, then you only have to write the first one, right?
Right, and if they're both no reaction, then you get to write
Yeah.
just the first one
That
for
makes
both
it
of them.
real easy.